Easy 3D Biz, giving you a update on how I make the formula for the battery. This is being put on so you guys can freeze frame it and read it later and write it down or whatever. Quite simply, I use a copper pipe. Half of the copper pipe has been oxidized, and then around the copper pipe I wrap a fiber paper, or the more fiber the better. Sort of like those hand towels you used to wipe your hands with. Basically, this hand towel, or basically the fiber paper, is saturated with galena powder, hematite, pyrite, peacock ore, and all the large chunks are removed. I only use the powder because the powder goes right into the fiber, and the chunks basically don't make this stick really well. I'll put 2.5 turns of the fiber paper around the copper pipe, and once that's done, it's saturated with Visine extra strength eye drops. They contain the superconductors dextran and PEG 400. After that's done, a layer of sodium silicate is applied around the fiber paper, and it's left to dry. It takes about an hour to dry. Next, we put together a paste consisting of the following. And when the paste is dry, basically the paste is put around here like this. So what we do is we use salt substitute, also known as potassium chloride. I don't know if you guys can see it, but there is a large amount of potassium chloride. It also has lysine in there. Lysine is very good for the adhesiveness, so I usually make sure the potassium chloride has the lysine, or the salt substitute. I put 1 part of powdered Epsom salt that's been crushed in a mortar and pestle, 1 part of potassium chloride. I then use 2 parts of sodium alginate. Sodium alginate is a superconducting polymer, and I do 1.5 parts of calcium chloride. I don't know if you guys can see this right here, but this is calcium chloride. It's basically like a nice powder. It actually increases the adhesiveness of the paste here, makes it stick really, really good. Then that's put into a little cup, and then I add 3 drops of of the Visine liquid eye drops. They're applied and they're mixed into a powder. This is done with drops of distilled water, just a little bit. It's all you need is a few drops until a paste is formed. This paste is applied over the dried sodium silicate, and it's allowed to dry. And when it's applied over the dried sodium silicate, it looks like this. It's like a rubbery texture feel. That's what we want, because we want to conduct the ions. The ions love basically a rubbery substance, and that's what we want. Next, magnesium ribbon, like this, is coiled around the pipe. It's placed to coil. It takes me about 3 turns to basically make a coil. And when it's done, you end up with this. And this is basically what you get. And I put duct tape on here to seal out the moisture, but that's basically what it looks like. And I put 3 of them in series right here. And basically we got LED, it'll drive it, it'll run it forever basically. And I put it in here, it's just a prototype. But that's basically what happens. It's very important the magnesium coil is dried. Sorry, it's very important that the paste is dried first before the magnesium coil is applied. Basically, we don't want to corrode we don't want to end up causing corrosion. So I always make sure that before I apply the magnesium ribbon, that it's all dry, because that's what's important. It will not corrode the magnesium once it's dry. So that's what we want. Then I short it out 3 times, about 15 minutes apart. I spend about 10 to 20 minutes on each short to boost the voltage. And basically we'll go ahead and do a voltage check here. See how many volts we're getting. I'm going to do this with 1 hand, by the way, so stand by. Alright. So you guys can see this, everything's a complete circuit right here. I've got this fella right here. Go and put it on the 2-volt scale. And I got a piece of magnesium ribbon right here simulating the magnesium coil. And I'll go ahead and put it across here. You guys can see that, but as you can see, it's just touching it. It's not force applied. It's the electrostatic ionic conductivity that's causing the energy. which is really cool because that means there's no corrosion. It can run forever. So basically the oscillation was increased by adding more galena, and I actually reduced the corrosion of the magnesium. As you know, magnesium and lead corrode. I put the magnesium on the bottom on the fiber paper, so we've got a very powerful little ionic conductor right here. And once they're done, connect them all up, and you're ready to go. So once again, it's Easy 3D Biz. Thank you for watching. Wish you all luck and success on your research, and have a great week ahead. Thank you. Bye.